Hi there everyone, and welcome to our first weekly lesson of our 30-week exam countdown. So you're tuned into the Leaving Cert higher level exam week 1 of the countdown. So we're going to be here every Tuesday during term time at 6:45 for roughly 30 minutes, okay? And our full members, you will have access to lots of videos, lots of the marking schemes and lots of notes as well for online on our TheMathsTutor.ie website. So you're going to see here, I have a couple of links posted in. So at the very top up here, that's a link for our full members, and it's also in the chat there to reach the exam countdown revision schedule. And you'll also see just here, I have 2 sample exam questions videos linked as well. So even if you're not a full member, you will have access to those from the chat from these videos. Okay, so you will notice our first week is all about algebra and a little bit of functions in there too. So we're going to kick-start it. We're going to go straight in. I will come back to these exam questions later. We'll be having a look at 1 or 2 of them. But we're going to go straight in and we're going to talk about a little bit about some of the equations, the different types of equations that we might be asked to solve in Leaving Cert higher level maths. As you know, algebra is a huge part of the course, and it will normally come up mainly in paper 1, but there is quite a bit of it obviously in paper 2 as well. So the 3 main types of equations that you'll be asked to solve in algebra are, we have linear equations. So an example of a very simple linear equation might be 3x plus 9 equals 0. Okay, the reason it's a linear equation is because, as you'll see here, the highest power of x there is 1. Okay, so it is an equation of degree 1, or usually more often we call it a linear equation. The second type of equation that we might be asked to solve is a quadratic equation. You'll be very familiar with these, especially from junior cert. And an example of that might be x squared plus 4x plus 3 equals 0. The reason it's called a quadratic equation is because it has an x squared in it. So anything with an x squared is going to be your quadratic equation. And the last type of equations that we might be asked to solve are cubic equations. And a cubic equation is one that has an x to the power of 3 or an x cubed in it. And it might already also have an x squared, it might have an x term, and it might have a constant. But it's a cubic because the highest power of x is a 3, or it's an equation of degree 3. Okay, so for this half an hour, we're going to spend a lot of time talking about quadratic equations. Okay, so we're going to focus a lot on quadratic equations and on the different ways of solving quadratic equations. This is something that will come up in some form or other every year on paper 1. You will be guaranteed that you will be asked to solve a quadratic somewhere. Okay, so how do we solve quadratic equations? Well, there's a couple of different ways. So when we're solving them, one way is we might decide that we're going to factorize it. So factorizing is our first way of solving quadratic equations. You're probably familiar with that. So that's guide number or taking out what's common. The second way might be our minus b formula, or as it should be known, the quadratic formula. Okay, and sometimes we can also solve quadratics graphically. So if we have a picture of the graph of the function, the quadratic function, we can solve it using that graph. Okay, so we're going to talk a good bit today about minus b formula and graphically, and we're going to just interlink both of those. Another way of solving quadratics, of course, is using the complete the square method. So any of our full members, there's a link to the complete the square video. You'll see that on our week 1 of our exam countdown as well. Okay, so let's get straight into it. We're going to start with a nice simple quadratic equation. I'm using the notation f of x, which just means it's a function of x. So x is the variable in the function, and sometimes we will call that y as well. So y and f of x are used interchangeably in questions, and they both mean exactly the same thing. So if we start with f of x equals y is x squared plus 4x plus 3 equals 0. So that's my first function. And what we're going to do is we're going to solve this equation, solve this quadratic equation, and we're going to do it using the minus b formula. So you'll be familiar with your minus b formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. You can find that in your log tables on page 20. And the first thing we need to figure out is what's our a, what's our b, and what's our c. So your a will always be the number in front of your x squared. Now you see there that we don't have a number in front of the x squared. There's an invisible 1 there. So if there's no number in front of the x squared, it's an invisible 1. Our b will always be the number in front of the x. So that's going to be our 4. And our c, sorry, that should be 4. And our c is always going to be the constant at the very end, which in this case is 3. Okay, so once we have figured out what a, b, and c are, we're going to sub those straight into our quadratic formula. Okay, so we're going to sub them right in over here into our minus b formula. So it becomes x equals, if I was to graph my quadratic, if I was to graph that quadratic, the x squared plus 4x plus 3, we know because it has a positive value of x squared, so because this is a positive number here, it's going to be U-shaped. So if it's a positive value of x squared, it's going to be U-shaped. If it's a negative value of x squared, n for negative, it's going to be n-shaped. Okay, so if we were graphing it, just a rough sketch, we know it's definitely going to be a U-shaped function. And the significance of your two answers, your two roots, x equals minus 1 and x equals minus 3, those are the points at which that graph is going to cross the x-axis. So because minus 3 is the smaller one, this point right here will be minus 3. And because minus 1 is the larger one, that point is going to be minus 1. So we're really just going to be interested in our roots, first of all, and the significance of those roots. What they look like on a graph. They are exactly where the graph is going to cross the x-axis, and the shape of the graph. So if it's a positive value of x squared, as I mentioned, it is a U-shaped function. If it's a negative value of x squared, it's an n-shaped function. Okay, so let's just try another one with a slight difference this time. This time, the function we're going to try solve is f of x, which we know is also the same thing as y, is 4x squared minus 12x plus 9 equals 0. So again, we're going to use our minus b formula. We need to figure out what our a, our b, and our c are. So our a is the number in front of the x squared, that's 4. Our b is the number in front of the x, be careful, it's a minus 12. And our c is the constant at the end, which in this case is a plus 9. We're going to sub that straight into our quadratic formula, and that's going to give me x equals minus b, so that's minus 12. Notice that when I'm subbing them into the formula, I'm always using my brackets. Plus over minus the square root of b squared, so that's minus 12 squared. Very important, the minus 12 is in a bracket there, so that when we put it into the calculator, the minus is squared as well as the 12. Minus 4 times a, which is also 4, times c, which is 9. And that's all over 2 times a, which is 2 times 4. Okay, this time I'm just going to draw your attention to what's underneath the square root here. Okay, so not the square root itself, but what's underneath the square root, that's where our b squared minus 4ac came from. Okay, our b squared minus 4ac has an important name. It's called our discriminant, and that discriminant is very significant when we look at the roots of a quadratic. So you'll notice, and I didn't draw your attention to it at the time, but you'll notice in this first quadratic that we looked at, this one up here, that discriminant was 4 squared minus 4 times 1 times 3. So if you worked that out individually, if you just put that part into the calculator, 4 squared is 16, minus 12, our discriminant up here worked out to be 4, which was a positive discriminant. It was greater than 0. So because that was a positive discriminant, because it was a number that was bigger than 0, that's why we got 2 roots. That's why the graph crossed the x-axis twice. When we work out our discriminant down here, we're looking at minus 12 squared, which is going to give me 144. And we're looking at 4 times 4 times 9, which is also 144. So that will give me 144 minus 144, and that gives me a discriminant of 0. So essentially, what that does is it deletes this whole part of the minus b formula. So what we're left with is x equals minus 12 is just plus 12, and we just have 8 on the bottom line. We're adding 0 and we're subtracting 0 for our 2 answers, and that won't make a difference to our answer. So 12 over 8, we know, can be simplified to 3 over 2. So we're actually only getting one answer here. We're just getting one root. Okay, and what that means, what the significance of my discriminant being 0 means, if I was to draw my quadratic, again, it's a positive value of x squared, so it's definitely going to be a U-shaped graph, but this time it's not cutting the x-axis at 2 points, it is simply just, it's not a very straight line, but it's simply just sitting on the x-axis at that 1 point, and that point for this quadratic is x is 3 over 2. Okay. We will also, so on our exam countdown, you will also see where we look at examples where the discriminant, so what's underneath the square root here, is negative. And if that's the case, the 2 roots are complex, okay? Or they have an imaginary component to them. So they're complex roots. And if that's the case, the U-shaped function would literally float above the x-axis. It wouldn't cross the x-axis because the x-axis is obviously our real axis. Okay, so let's just have a look at an example from the exam papers. This question is taken from the 2021, so last year's exam paper. It's paper 1 and it is question 3. And we're just going to have a look at B part I for now. Okay, so it's giving me the same notation, that f of x notation, which we know is exactly the same thing as y. It's giving me a U-shaped quadratic because it has a positive value of x squared here. It's telling me that x is a real number, so we're not expecting complex roots here. And we're looking for the 2 roots of the function. So when that function is equal to 0, what are my 2 roots? So the first thing we're going to do is we're going to write f of x equals 0. So that's 3x squared plus 8x minus 35 equals 0. And we're going to find our 2 roots. In other words, they want us to solve that quadratic equation. If you want, you could solve that quadratic by using guide number, by factorizing it. Or if you like, we can use minus b formula. I'm going to use minus b formula here because my guide number would work out to be quite a big number. It would work out to be minus 105. And that's fine, but minus b formula is going to work every single time. So I'm going to make sure that I write down my formula. And that makes it easy then for me to just substrate into my formula. So again, as we always do, we're going to work out what A, what our B, and what our C are. So again, our A is the number in front of the x squared, our B is the number in front of the x, and our C is the constant at the end. So our A is 3, our B is 8, and our C is minus 35. Subbing into my minus b formula, that's going to give me x equals minus 8 plus over minus the square root of 8 squared minus 4 times 3 times minus 35. All over 2 times a, which is 2 times 3. We're going to put that straight into the calculator. The first time we put it in, we will use our plus here. And then if we keep it on the screen, it's nice and easy to go back and just change that to a minus. Okay, so your 2 answers should be x is equal to 7 over 3 and x is equal to minus 5. And I'm just going to highlight my 2 answers or put a box around them, make them stand out in your answer. Okay, and that's That's as simple as it is. We're just using the minus b formula and we're throwing our quadratic straight into it. We weren't asked here, but if we were asked to draw the function or give a rough idea of what the graph of that function looks like, it's a positive value of x squared, so it's going to be a u-shaped function. It has two roots because our discriminant worked out to be a positive number, and that means it's crossing the x-axis at two places. -5 being the smaller of the two numbers, so that's furthest to the left, and 7/3 being the bigger of the two numbers, so that's closer to the right-hand side. Okay, so that's just our basic solving quadratics. And as I mentioned, you've loads more examples, loads more videos of those on your exam countdown week 1. Okay. We're going to have a very quick look at quadratic inequalities next. So you will see this question that I have here is from the 2018 paper. Immediately looking at it, it doesn't look like a quadratic because we don't see any x squareds anywhere. Okay, so let's have a look at what they're asking me in the question. They're asking me to solve that inequality. So when I see the word solve in a question, I am expecting that I will get an answer for x. I will work out what x is. It's telling me x is a real number, and it's telling me that x cannot be equal to -2. And the reason x cannot be equal to -2 is if x was -2, then the denominator here would work out to be 0, and we cannot divide by 0. Okay, so let's have a look. We have 2x minus 3 divided by x plus 2 is bigger than or equal to 3. So what you would normally do here is you would find your lowest common denominator, which in this case is your x plus 2, and you would multiply both sides of the inequality by the x plus 2 on the bottom. But we have a problem. When it's an inequality as opposed to an equation, we have an inequality sign there instead of an equals. If that was an equation, if we got minus x is equal to plus 5, if we wanted to solve that equation and find what x was, we would need to change the signs the whole way across. In other words, we would need to multiply across by -1. And that would change the left-hand side to plus x, and it would change the right-hand side to -5. And that's absolutely fine to do when it's an equation. But if I change that equal sign to a greater than sign, when we multiply across by -1, yes, we change the sign on the left. Yes, we change the sign on the right. We multiply that by -1 as well. But we also must change the inequality sign. So that's the one big difference between inequalities and equations. With an equation, if you multiply both sides by a negative number, you just simply do that. You multiply the left by a negative, you multiply the right by a negative. With an inequality, if you multiply across or divide by a negative number, you must change this inequality symbol to the opposite as well. So we can't just decide to multiply both sides here by x plus 2 because we're not sure if x plus 2 is positive or if it's negative. If x, for example, was -3, then x plus 2, so if x was -3, then x plus 2 would be -3 plus 2, which would be -1, which essentially would then be me multiplying across both sides by a negative number. And that would require me to change the inequality sign. So to avoid the chance that x plus 2 is negative, which it might be, what we do is we multiply across by something that we know is definitely positive. And we know that when we square anything, it's definitely positive. So what we do is we multiply the left-hand side by the denominator, but squared, because we know that's definitely positive. Whatever you do to the left, you must do to the right. So we also multiply the right-hand side by x plus 2 all squared. And look what happens when we do that. This x plus 2 on the bottom is going to cancel with one of those x plus 2's on the top. Because remember, x plus 2 squared is just x plus 2 by itself. So the x plus 2 on the bottom cancels with one of them on the top. And now what we're left with on top, we have an x plus 2 times a 2x minus 3 greater than or equal to 3 times x plus 2 squared. All that's left to do is just multiply out those brackets and solve the resulting equation. So on the left-hand side, I'm going to split that first bracket and I'm getting x by the second bracket and plus 2 by the second bracket greater than or equal to 3. And I'm going to do Bimdash first. So I'm going to work out the indices or the powers here first. You can, if you want, multiply x plus 2 by x plus 2, as you normally would back-to-back brackets. Or the nice quick way, we square the first term, which is x, and we're squaring it. We square the last term, which is 2. So when I square that, that's 4. I multiply the first by the last. That gives me 2 by x, which is 2x. And I double that. So that's giving me plus 4x. So multiplying out the left, I'm getting 2x squared minus 3x plus 4x minus 6 bigger than or equal to 3x squared plus 12 plus 12x. So I've just multiplied in the 3 on the right-hand side. Okay, so that's giving me 2x squared plus 1x. So minus 3 plus 4 will give me plus 1x minus 6 greater than or equal to 3x squared plus 12 plus 12x. And I'm going to move everything to the left-hand side because now it is looking like a quadratic. It has an x squared in it. I'm going to move everything to the left. So that's giving me 2x squared minus 3x squared plus 1x minus 12x minus 6 minus 12 greater than or equal to, and I have 0 on the right. I have nothing left on the right. Simplifying, that's minus 1x squared minus 11x minus 18 greater than or equal to 0. Now, I don't really like seeing a minus out the front of an equation or an inequality. So what I'm going to do is I'm going to change the signs the whole way across. In other words, I'm going to multiply by minus 1. That's technically what we're doing when we're changing signs. So that will give me a 1x squared plus an 11x plus 18. But remember, we're multiplying both sides of the inequality by a minus 1. So we know that results in us changing the sign of the inequality. And 0 by any number is still just 0. Okay? So I'm just going to highlight that there. We're not finished yet because the question asked us to solve. But what we've ended up with is a quadratic inequality. How we're going to solve it is we're going to solve the equation on the left-hand side, or we're going to solve the quadratic on the left-hand side as if it was an equation. So we're going to throw that into the minus b formula. Okay, we're running out of time a little bit. So I'm just going to give you your answers as if, so where these are coming from is me putting this into the minus b formula. Your answers should be x is equal to minus 2 and x is equal to minus 9. So we've learned previously that these are our roots of the quadratic. In other words, that's where they cross the x-axis. That's where the quadratic that I've highlighted here, that's where that crosses the x-axis. So if I was to draw it, it's a positive value of x squared, so we know it's going to be a u-shaped function. It's going to cross the x-axis at minus 9, which is the smaller of the two numbers, and minus 2, which is the bigger of the two numbers, so that goes on the right. Now, this is where we need to solve the quadratic inequality. We are interested in where that quadratic is less than or equal to 0. So it's equal to 0 on the x-axis. It's less than or equal to 0 below the x-axis. So it's a good idea to draw a rough sketch of your graph and highlight the part of the graph that you're interested in. In this case, it's where it's below the x-axis. How do I know that? Well, because of what it says here. It's less than or equal to 0. If that was positive, greater than or equal to 0, I would be interested in above the x-axis. So to answer my question, we are interested in every single value of x in this range here. That's every single value of x that's going to be less than or equal to minus 2, but bigger than or equal to minus 9. In other words, x has to be between minus 9 and minus 2 inclusive. Okay? So that was just an example from the 2021 exam paper. You will notice in the chat we have included a link to another exam paper as well, the 2013 exam paper that includes a quadratic inequality. Okay, so I apologize for our technical difficulties at the start, and hopefully that was of some use to you. And I hope you can join us again for next week at the exact same time. Thank you.